Alright, good morning, Geometry Concepts. This is 11.4, Notes, Day 1, Area of Composite Figures. So we started doing this already, okay? What I mean by already is that we did a donut problem yesterday, and the double triangle one, where we are starting to do area of composite figures. And what you need to know about area of composite figures is that you can add them together. You can add or subtract areas. So let's just dive into here. So we have number 1. So what I would do is I would cut number 1 into familiar things. Meaning, I don't think that we have a formula for solving this. However, if I drew this red line in here, right, and I trace this red one, right, I look at this red one, and I see a trapezoid. So what I would do is I'd probably come over here and find the area of the trapezoid. So the area of a trapezoid is going to equal height, base 1 plus base 2, all divided by 2. So when I see this, I see area of trap instead of triangle. So height, so this height here, we got to do a little bit of math. Here to here is 12, but here to here is 5. So I would argue that this missing piece here for the height of the trapezoid is 7, because 5 plus 7 is going to equal 12. So let me get my red marker here. My height would be 7. My base 1 would be 8 on top, followed by the whole distance, corner to corner, of plus 15, divided by 2. So, knowing how to use my calculator, area of the trapezoid is going to equal 23 times 7, divided by 2. Alright, so 23 times 7, divided by 2. I get an area of the trapezoid is about 80.5 inches squared. Alright, then we also have this rectangle on the bottom. So this rectangle on the bottom, I could do in blue. This is a rectangle, all the lines are straight. You should know area of rectangles are going to be base times height. Rectangles are technically parallelograms, so it's just base times height. So I would argue the base is 15 and this height over here is 5. So the area of the rectangle is going to be 75 inches squared. And now for the total area, so area total, you need to understand it's going to be the area of the trap plus the area of the rectangle. So a lot of times you'll see kids write 80.5 plus the 75, you get 155.5 inches squared. Right. Now, on your quiz on Friday, one thing to note is maybe you get the area of the trapezoid wrong, but you do the area of the rectangle wrong. I'm just going to take 1 point off. Right? If you just write down final answers and you don't show any work, you're probably going to lose like 5 points. So you need to make sure that you're showing a little bit of work. Alright? So just make sure you get that you can add the areas together. So here we added the red trapezoid to the blue rectangle, and you get a total area of 155 inches squared. So on the top it says you can add or subtract areas. When I look at number 2, alright, we have 2 rectangles. We have one inside of the other. Right, so then I look at this, and I'm going to find the area of this whole thing. So this red one here, right, I would see top all the way to bottom. So over here, it says 25. So I would put the 25 here. And then it has another 25 on this side. So when I add these 3 measurements together, I get 70. So this is going to be 70 feet. And then the 100 has the same thing going on. Oops. The 100 here has 25 plus the 100. And then on this side, you're going to have 25 again. So the distance of this whole thing is probably 150 feet. And by probably, I mean that's what I want you to understand. So, we have an area with a height of 70. So when I do this, the shaded region, the whole shaded, including the inside, the area of the shaded, actually not even the area of the shaded, the area, let's go large rectangle. So the area of the large rectangle is going to equal base times height. So the area of the large rectangle is going to equal 150 times 70. So 150 times 70, you put that in a calculator, you get a really big number. Probably like 110,500 feet squared is equal to the area of the large rectangle. Now, on the inside here, we have this little rectangle right here. So then I have the area of the smaller rectangle in blue here. Now, the area of this inside, right, because that's what we got to subtract the large rectangle by, because we want to hollow out that large rectangle and subtract the blue one. So what I would do is base times height, because rectangles are going to be base times height. I would have 100 feet times the 20, and that's going to be 2,000 feet. So the area of the small rectangle is equal to 2,000 feet. So then here, to find the area of the shaded region, so SR, you're going to do the area of the large rectangle. So when you found that area of the large rectangle, the area of the large rectangle is everything on the inside. So it's all of this. So what you want to do is subtract that blue, which happens to be the area of the small rectangle. So you'd have 10,500 subtracted by 2,000. And that results in our shaded region being 8,500 feet squared. So make sure you can get 8,500. So the first one we had to add some areas together. The second one, you're missing something on the inside. So if it's not shaded on the inside, it's always going to be subtraction. So if there's a hollow piece in there, it's always going to be subtraction. Then we have 3. 3 is a little bit of multiple things going on here. Right? We need to see that we have, it says find the area of the figure below. So it's got 4 things, and it's actually nice. We can see nothing's hollow here, so we're just going to have to add things together. And then also, you just can see that they had laid it out for us, the 3 things we need to find. So area of a semicircle, I'm going to do it up here. So area of a semicircle is in blue here. Right? Area, semicircle, is going to be 180 degrees out of 360. Now if you look at that, and you can reduce that to 1/2, that's a really good skill to have. Or you should know semicircle stands for half a circle. So what we're going to actually do is have 1/2 of pi r squared. So area of semicircle equals 1/2 pi times 4 squared. So area here, or this radius was 4. It was given as 4. So that's 4 squared. So the area of the semicircle would probably be 8 pi. You could do 8 pi, or you know that we're going to add things together. So eventually, 8 pi is equal to 25.1. So I come down here, I'd write 25.1 feet. Then we'd have to do something else. And the next one is triangle. So we need to know that the area of a triangle is equal to base times height divided by 2. So looking at this, this is my right angle. So the sides here that I wanted to use, boy, we don't quite have the base and the height. But what we do have is we want this height here. So we're going to have Pythagorean theorem, h squared plus 4 squared equals 5.7 squared. So h squared plus 16, 5.7 squared is 32.49. So we subtract 16. Subtract 16, we have h squared equals 16.49. When you square root both sides, you're going to get height equal to the square root of 16.49. And that is going to be 4.1. So I come over here, and I would go area of my triangle. So if this is 4.1, remember triangles, you have to pick the two that are perpendicular. In this case, our base, I would probably say it's upside down. I'd say my base is 4. My height is 4.1 divided by 2. So this is going to be 8.2 feet squared. So area of a triangle is 8.2 feet squared if you plug that into a triangle. Now, area of a rectangle, so area of a rectangle is going to equal base times height. And this one, it's got a skinny base of 4 times a height of 7. And you would find out that that's 28 feet squared. Ooh, it looks like I forgot one label. And that would be the feet squared on the area of a semicircle. However, the total area, well, I would actually just need to add these three together. So 0.1, 0.2 is 0.3 squared, right? And then you'd have 25, 28, and 8 in a calculator. You should get a total area of the figure of 61.3. So you could write area total equals 25.1 plus 8.2 plus 28. So you are just adding all these together, and you get 61.3 feet squared. So these composite figures, so the vocab word's composite. That means to put together things. So composite means to put things together, so we're putting a bunch of areas together and finding out the total area of the figure. Find the area of the figure below. So we broke it down for you. There's two of them. They argue that there's an area of a semicircle and an area of a trapezoid. So this is the semicircle again. Alright, I don't see anything useful there. However, I do see that I can draw a height here. And why that is useful is because I can now figure out what this distance is. Right? Because I need to find the height. There's no height given. So 31 would be the distance from corner to corner. But if I subtract the 22, that means it's 9 longer. Well, where's the 9 come in? That's where the extra 9 centimeters are, from that corner to that corner. So, in a nutshell, we have this triangle here that's 15, 9, and H. So, favorite thing in the world, Pythagorean theorem. So we'll have 8 squared plus 9 squared equals 15 squared. 8 squared plus 81 equals 225. Subtract 81 equals 144. You square root. H is going to equal 12. Now, if I'm going too fast for you, you should have good note-taking skills. You could pause it at any time, write down what I'm saying, and then try to re-listen. So this height is 12 centimeters. So what I needed that for is a couple things. We needed it for our semicircle, because now our area of our semicircle is going to be equal to half a circle, but it's going to be pi, and we just found if the height is 6 all the way, or 12 all the way across, 12 would be the diameter, and Jameson Lemke would tell me 6 is the radius, so we'd have 6 squared. So when I do that, the area of the semicircle is going to be approximately 6 pi, or when you do 6 pi in your calculator, you have a whopping total of 18.8. That's a decimal in there. So 18.8 centimeters squared. Then the next thing we would look at, is our area of a trapezoid. So I'm arguing with you that this thing here is a trapezoid, because I only want to do two of them. I don't want to do a rectangle and a triangle. I just want to do one. So I would argue this is height, base 1 plus base 2 over 2. Remember, area of a semicircle is 1/2 pi r squared, if you really needed that formula stuff. So area of the trapezoid is going to equal, the height is 12. It'd be 22 plus 31, all divided by 2. So the area of the trapezoid is going to equal 22 plus 31 will give you 53, times it by 12, divided by 2. You get 318 centimeters squared. 318 centimeters squared. So sweet. This is easy enough, because 31.22 times 12, sweet. You have an area of the total thing equal to those two things added together, so you get 336.8 centimeters squared. Alright. So, moving on. The radius is 6 squared. Oh, it's 18 pi. I figured out my mistake, people. So if anybody caught this, you can tell me about it tomorrow. But this would be 18 pi here. Don't know why Jason told me the wrong values in the calculator. So that's 56.5. So this is 56.5. And then, awesome sauce says that the area of the total is equal to 374.5. So I was looking at my notes, I couldn't find my mistake, blah, 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 blah. That's why we make mistakes on purpose, so we can correct ourselves. And last but not least, let's go over to number 5 on the back. So number 5 on the back, find the area of the shaded region. So this is a parallelogram. Alright? Good news is it's actually pretty easy, because the area of the parallelogram is equal to base times height, which is equal to 9, blah, 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 blah. The base is 14. Base of the thing is 14. So the base is 14. The height, the 9 is perpendicular here. So when I see that 9's perpendicular, that is great news, because then I can just multiply and make sure you're checking my math, because I haven't screwed up in at least 2 minutes. 126 feet. So this is 126 feet squared. Now, the beautiful thing about this problem is this is a kite in the middle. Okay, you should be able to see that's a kite. Now, what makes that beautiful is this is one where we're going to take the area of the shaded region, and that's going to equal the area of the parallelogram minus the area of the kite. Since this is hollow in the middle, meaning the shaded region is just on the corners and stuff, this has to be a subtraction one. So I would do the area of the kite, and area of the kite, remember, is diagonal 1 times diagonal 2 divided by 2. Well, the area of the kite is actually just going to be 9, because from here all the way up and across is 9. That's why it's perpendicular. Now these parallel symbols, these little triangles in the middle, alright, that is a mid-segment theorem type deal. And that should tell us, that that is equal to 14. Since these are parallel, this has to be 14 as well. So divide by 2. So the area of the kite is actually going to be 63 feet squared. So then I go area of the kite, 63 feet squared. So the area of the shaded region if I did this. Area, shaded region, is going to be 126 feet squared minus 63 feet squared. And the area of the shaded region is 63 feet squared. Alright, if you have any questions, please let me know tomorrow when I get here. Otherwise, you have Miss Azelson, third hour. Second hour, you're kind of on your own. That's why we have Mary and other people to answer questions. When I get back Thursday morning, if you're confused, you should see me in academic support. Right? So your homework's here. Make sure you are behaving. Otherwise, we'll have consequences appropriate on Thursday. Thank you. Have a great day. Don't do anything I wouldn't do.